So welcome everybody. This first slide that you're seeing as you're coming on to our webinar is our brand new virtual program. So if you don't get it written down right now, no worries. We're going to talk about it again at the end of class. Hi, how's it going everybody? Welcome to At Home with Mote. I am Miss Dana. Dana Henderson is my full name, but you guys at this point all know me as Miss Dana. It is our last At Home with Mote of the season. Thank you guys so much for your support of these virtual homeschool programs. They've been a lot of fun, and if you guys have liked them, let us know because you never know, we might end up being able to do them once a month or something in the fall. So we'll try some things out. I'm so excited though to be getting things back to normal, and hopefully in the fall you guys can all come and visit me on site. Well, today I had to end our program. I had to end the At Home with Motes all about sharks, right? Because we're here at Mote Marine Laboratory. Sharks are kind of our thing. I mean, just look at our logo, right? So we're going to kind of get at home with sharks a little bit today, kind of learn what makes a shark, maybe bust some myths about sharks. We have a couple of fun activities to do. So if you have the pre-lesson guide and you were able to prep the little smell activity beforehand, you can do that along with me. If not, no big deal. You guys can go and do it later and just watch with us, okay? This presentation will be available on our Flipgrid afterwards, so you can go and check out the presentation, and then of course the live recording will be available next week for you guys. So just a couple of reminders as far as Zoom goes. This is a webinar, so you can't chat with each other, but you can chat with our hosts. So right now we actually have three amazing moderators with us today. We have Miss Elena, we've got Mr. Brad hanging out with us today, and we've also got Miss Kaylee, and they're all going to be helping to moderate and answer questions. So you guys know if I'm sharing my screen or if I'm kind of in the middle of a spiel, I may not see your chats pop up, I might not see your question, but my team of professional educators will answer all those questions for you, okay? So you can ask questions, you can also answer questions in those chats. You guys know I like this to be interactive, so I'm going to teach as if you're in the same room with me, okay? Ask questions. If you have any tech issues or anything, you can also put those in the chat, and those guys will be happy to take care of that for you. So all right, so you guys ready? Let's get sharky today, all right? So I'm gonna go ahead and share my screen with you guys. I also have some fun things to show you. Okay, so awesome summer. I'll tell you guys more about that at the end. All righty, At Home with Sharks. Well, you guys are in the right place to learn about sharks, you guys. We were founded back in 1955 here at Mote Marine Laboratory by this lovely lady here, affectionately known as the Shark Lady. This is Dr. Eugenie Clark. She busted so many myths about sharks. She was one of the first female shark biologists, really one of the first female scientists out there, okay? Just really paving the way. So it's really cool to be a part of her legacy, okay? So we were started to study sharks. Now, since then, as you guys know, we've kind of branched into all areas of marine science. Anybody just joining us for the first time today, we are with Mote Marine Laboratory and Aquarium. I'm coming to you live from here today. And yeah, we are a shark research facility. We have a lot more going on now, so we're studying coral reefs, sea turtles, manatees, you name it. But sharks is what we were started to study by Dr. Eugenie Clark. She was this wonderful lady. We just lost her a couple years ago. And guys, she had spent her 92nd birthday scuba diving the Red Sea, leading a scientific expedition. So the ocean keeps you young, and sharks keep you young too, guys. So. Now we have a couple of active research programs going on here at Mote. So again, you are in the right place to learn about sharks. This is Dr. Carl Lohr. He's kind of a big deal in the shark world, and he runs our marine biomedical research program. So sharks, skates, and rays, they have a low rate of cancer. They heal really quickly, okay? So Dr. Lohr is studying that. So guys, sharks may actually hold the key to curing cancer one day, which is really incredible. Our other program we've got going on right now is run by Dr. Bob Huter. If you've ever seen any of the O-Search videos, I'm not going to show one today, but I highly recommend you go out and you check them out. They are expeditions where they go out and they tag these great white sharks to learn all about them, okay? And Dr. Huter is one of the lead scientists on those boats. This is a picture of him tagging a whale shark in the bottom right, okay? The top right corner is a spotted eagle ray, which is an amazing species of stingray, cousin to the shark, that we find out here in our bays, that there's not a whole lot known about their life history. So him along with his team are figuring out where they go, what they do, and of course, guys, how we can conserve them, because they're pretty amazing animals. All right. Well, now we want to figure out, well, what makes a shark a shark? But before we get to that, I kind of want to know how you guys feel about sharks. Anybody scared of sharks? Anybody get a little nervous when you're in the water? Okay. What do you think about sharks? So before you tell me, I want you to do one thing for me. Close your eyes. Ooh, take a nice deep breath. You guys know we love to start our classes with a nice deep breath, right? Let all that negativity go because we're learning about sharks. Close those eyes. Picture a shark in your brain. What's it doing? What's it look like? Is it a certain species? Okay. Think of one word to describe that shark. I'm not going to say giraffe for those of you guys that have been to all my programs. Normally my first word is giraffe, but today it's not going to be. So everybody open those eyes. What did you think of? What were you picturing when you were thinking about that shark? What's one word? Let's all say it together. 1, 2, 3. Beautiful. Oh, amazing, mesmerizing. These are the words I think of when I think of sharks. What did you guys think of? Type in the chat a word that reminds you of a shark. Did anybody picture the biggest shark? The whale shark that grows up to 50 feet? That is the size of a school bus, yet eats the tiniest little creatures out there. Maybe you pictured the smallest of all the sharks. Doesn't get longer than a pencil, you guys. The dwarf lantern shark, tiny. A lot of times when we think of sharks, we think of big. But 80% of sharks, you guys, can cause no problems to humans at all because they're either so small or we never see them, okay? So this dwarf lantern shark, about 1 foot long and has bioluminescence. That's where it gets its name. Pretty incredible animal. Did you picture the fastest shark? How many of you guys pictured a shark using that torpedo-shaped body, that fusiform-shaped body to swim, okay? Those huge pectoral fins right here, you guys, that provide them lift like the wings of an airplane, or that amazing tail that gives them that power and strength. So boys and girls, this is the fastest shark. This is the short fin mako. And Mote Marine Laboratory scientists were actually able to tag some of those off the coast of Cuba, which is pretty incredible. We tag them so we can figure out where they're going, where they need our protection, and what are they doing. Did you picture a shark with the best camouflage? This is the wobbegong shark. This is a type of carpet shark, okay? And these guys, they're not swimming around fast like those mako sharks, right? They are perfectly adapted for camouflage, okay? So maybe you pictured a guy hiding out, a hide and wait predator, a ambush predator. He has all these special little things sticking off of his little cirri sticking off of his head that looks just like seaweed. I mean, it is incredible. Did you picture a fierce predator like the white shark, also known as the great white shark, okay? A lot of times around here, when our scientists are chatting with each other, they very rarely call it the great white shark, even though we all know how great it is. We just call it a white shark, okay? And the fiercest predator out there, right? One of the only fish that can actually regulate their body temperature a little bit, okay? These guys are amazing. And Dr. Huter will go out and actually work with that team, OSEARCH, to tag these white sharks, figure out where they're going and what they're doing. So maybe you pictured that shark. How many of you guys pictured a great white shark when you were imagining a shark? Maybe you didn't picture a predator at all. Maybe you pictured an animal that's a filter feeder, like the whale shark. This, guys, is one of my favorite sharks. We don't actually have these in the Gulf, as far as I know, but I have seen these in the wild. This is called a basking shark. And they're big and they're slow and they just, they usually like cold water, so you usually find them up north, but they have that big old mouth that is used to filter out krill and plankton, and just like the whale shark does, right? So these guys aren't predators hunting down their food, they're filter feeders. Maybe you pictured the very first omnivorous shark. You guys, I am so fascinated with how science changes, and the more we learn, boys and girls. We used to think that sharks were only carnivorous, they were only meat eaters, and this little guy here is the bonnethead shark, who scientists now know are omnivorous. What does that mean to be omnivorous? If you remember, if you know, type that into the chat. What is an omnivorous animal? Yeah, you guys got it. An animal that eats both meat and plant material, right? Okay, so we think of a manatee as being only herbivorous, only eating plants, and we typically think of sharks as only being carnivorous, okay? Every now and then we'd find some seagrass or something in the belly of a bonnethead shark that passed away, that we did what we call a dissection, or to figure out what happened. We would find some seagrass in there, and the scientists would think, oh, well, must accidentally be eating that seagrass because it's going after crabs and shrimp. Well, after much scientific research, okay, the scientific community now agrees that these guys sometimes just go after the seagrass, okay? So the first known omnivorous shark. Did anybody picture a bonnethead shark? It is so exciting, boys and girls. Every now and then we'll see these guys when we go out into the water. They'll literally swim right around our feet, and you don't have to be scared at all. They are tiny, they are looking for crabs and minding their own business. So I love it when we see these guys out in the field. Did anybody picture our shark scientist when I had you guys close your eyes and picture sharks? Did anybody picture swimming with a shark? Because that is exciting. There's nothing quite like it, okay? So when we're in the water, we just have to make sure that we respect them and we know that it's their home. But I had some of the most incredible times of my life scuba diving or snorkeling with a Caribbean reef shark or a nurse shark. Now, I have never seen whale sharks in the wild, you guys. So if you have, go ahead and let us know on chat, because I am so jealous. It is on my bucket list, you guys. Now, if you ever do go swim at these gentle giants or anything like that, again, you always want to practice those good ecotourism practices we've talked about in the past, and you want to make sure everything has distance. These guys that you're looking at here, Jack Morris and Dr. Bob Huter, they have special permits to go up to these guys, so you would never want to go up and touch them. But how many of you guys pictured a shark scientist? How many of you guys maybe want to be a shark scientist when you get older? Come work here at Mote. Did anybody picture a silly shark? How many of you guys have heard of this movie? I don't recommend watching it, okay? But Sharknado. There's a lot of sharks on TV, right? We hear so many things about sharks all the time. There's all these silly movies. When I was researching for this program, there's a movie with about a three-headed shark and all these silly things that are totally fiction, okay? Can you guys think of another movie that was totally fiction that came out that scared a lot of people and turned a lot of people against sharks? So you might know, some of you guys may have seen it, some of you may. I don't really recommend watching it unless you can watch it completely knowing that it's fiction. Jaws, you got it, Jaws. So we have to remember stuff like this, totally fake and silly. Did anybody picture a cute shark? Are you singing the song right now? I don't own the rights to that song, so I'm not going to sing it, but did anyone else picture a cute shark singing the cute shark song? What about scary sharks? Did anybody, when you were picturing a shark, did anybody think, or did anybody get scared? Did anybody think their word, when we said all of our words, did anybody say scary? Did anybody say deadly or dangerous? What do you think? Because if you did, you're not alone, okay? More people are scared of sharks than, I mean, it is one of the #1 phobias out there. But it also makes for good TV, right? If something happens with a shark, we see it, okay? We see it and we hear about it right away, okay? But what do you guys think? How dangerous do you think sharks really, really are to humans? Okay, we know they're that apex predator, okay, meaning they're at the top of the food chain. And we know we need to respect them. But in the grand scheme of things that are dangerous to humans, what do we think? So guys, we're going to do a little most dangerous lineup here. So if you had your pre-activity guide and you went ahead and cut out your little blocks of animals and things, you can go ahead and get those now. If not, just follow along with us. So ladies and gentlemen, I am going to list off 10 things that could be potentially deadly and dangerous to humans, okay? Now, boys and girls and ladies and gentlemen, the point of this activity is not to make you scared of all the other things, okay? So we're gonna just keep an open mind and know, you know, that some of the things, maybe they're dangerous, but we're not gonna be scared. We're gonna learn, guys. We're gonna learn, and that's gonna give us power, okay? So, let's see, let's list these off, and then you guys help me put them in the least dangerous to humans to the most dangerous. Okay, now talk about it if you're with your friends or family, okay, if you're with your family, or even in the chat, talk about why you think these are dangerous or not, okay? So whichever one you think is the most dangerous, let us know why you think. First one is a dog, a shark, a selfie, a lightning strike, driving whilst texting, a coconut, a mosquito, a hippopotamus, a snail, and last but not least, a snake. Which of these do you guys think is the most dangerous to humans? So we're just going to take about 30 seconds, so we're going to go quick. And you guys try to line them up. And then we'll see, which do we think is the most dangerous? Okay, so which one of these do you think causes the most accidents per year? Let us know why. Why you think? I'm going to look at the chat while we're doing this. Ooh, hippo, Angela, good guess. Texting while driving. Ooh, okay, all right. Good job, guys. Ooh, Amelia, good follow-up. She says mosquito because of all of the diseases they carry. Coconut. Oh, hi, Dana. Texting while driving. Yes, okay. It's kind of hard, right? You're like, oh, well, none of these sound very good. So let's see. Any last minute changes? All right. These are the facts, okay? So these numbers are the numbers of human-related fatalities, okay? So did not end well for these guys. So first one, look at that jump, guys. This particular thing caused 725,000 deaths. Sounds so morbid to talk about it, but it's true. The mosquito, did you guys get it? So because of disease carrying, so Amelia, you are exactly right, the mosquito. So important that we protect ourselves from mosquitoes, right? Make sure you don't have standing water around. I know they're really bad at my house right now. My cat developed a mosquito allergy, if you can believe that. So number 2 with 50,000, which do you think it is? The snake, the snake. Now this is from both constriction and accidental, like stepping on them and getting bitten. Again, guys, this is not to make you scared of snakes, okay? You guys know I love snakes, all right? This is just to give us a healthy respect, right? And to kind of give us a little bit of perspective. All right, number 3, what do you guys think it is? Texting while driving. So guys, if you don't take away anything from this class today, take away that this is bad news when you guys start driving. Just put it away. Texting while driving. Look how many deaths a year. Bad news. 25,000. Dogs. And I know I love dogs, right? So yeah, so from rabies and from just different things around the world. So again, this is a worldwide poll. Again, don't be scared of your dog. Just give them that healthy respect. All right, 10,000. The very deadly snail, the freshwater snail. Who got that? Yes, from eating escargot. And there can be a parasite in there. I've never actually had escargot. Have you guys? Interesting. With 6,000 a year, lightning strikes. Lightning strikes. 500, the hippopotamus. And then it jumps down, guys, 68 a year. And think about it, guys, hippopotamus are only in Africa. Selfies, 68 people a year may die from selfies. They're walking out into traffic. They're falling off of cliffs. So guys, I recommend don't walk and selfie at the same time. Number 23, coconuts. Coconut can fall on your head and makes for a bad day. And finally, last but not least, measly little 10, more likely to walk off a cliff while selfieing, the shark, the shark. So how many of you guys got it? You guys probably knew that the shark was at the end, right? So that's what this is all about, guys, just to kind of break some of those misconceptions that sharks are just mindless man-eaters and they're out to get us. It's usually accidental encounters, okay? And that's something that our Mote researchers are trying to do. They're trying to get rid of that stigma of the shark attack because that doesn't usually happen. Usually a shark will bump them with their snout and then just leave, okay? So there are some things that you can do to avoid being those 10, right? Because we still want to swim safely, okay? So when you're out in the water, just remember it is their water, okay? And you are just a guest there. But it's always, sorry about that, guys. It's always important to swim with a friend or a companion. Okay, if you notice a lot of fish in the area or something like that, that could be a shark feeding there. Now, typically they are feeding at dusk and dawn. Okay, so if you avoid swimming during those times, okay, if you're not if someone's standing in the water, you know, like chumming the water with like bait and stuff like that, you know, maybe don't swim then. So just kind of use your common sense, right? And you should be fine. Now, you don't want to swim with like an open sore for many reasons, not just sharks, but you don't want to get any sort of bacteria in there. Now, the old myth of a shark can detect one tiny drop of blood in an Olympic-sized pool has kind of been busted, but they still have a really good sense of smell. So if you're bleeding at all, just for many reasons, maybe don't go in the water, okay? All right. Good job, ladies and gentlemen, picturing your sharks, busting myths about how dangerous those sharks are. So now I just want to quickly go through and let's learn what makes a shark, because I have some fun things to show you, okay? So What makes a shark a shark? What do you guys think? So each one of these classes, we've kind of gone over characteristics of animals and kind of why they're put in certain categories, their taxonomy, if you will, their classification, right? How scientists study them and group them, okay? So does anyone know what group we have in common with sharks, okay? There's something that we as a human have in common with a shark. Can anybody think? What do you think? I'll give you a hint. It's our same phylum. We belong in the same kingdom and phylum, if you know all that. So what kingdom are we in? Do we share with the shark? Yeah, good job. Animalia, the animal kingdom. So we have that related to sharks. And then we're actually in the same phylum. Phylum Chordata. If you feel those bumps along your back, everybody have their vertebrae with them, their spine. No one left it at home today. Well, you're at home, so it's probably at home, right? So we have that in common. Underneath that, guys, we are in class mammals, and that's when our friends, the sharks, switch, okay? Those sharks are fish, but they're not just any old fish. What kind of fish are they? They are cartilaginous fish. Let's all say it. Cartilaginous fish. I was literally practicing different ways to sing words on the way here today, and they still all came out like the Activia commercial. Cartilaginous. Cartilaginous. That's a little better, maybe. I don't know. So these are cartilaginous fishes. They are class Chondrichthyes, okay? The bony fish are in class Osteichthyes, okay? So a little bit different. Everybody take your finger and wiggle your nose. Wiggle your ears. Okay, that cartilage. Now imagine your whole body is made of that cartilage. How bendy and flexible you would be. Cartilage is also much lighter, okay? Now, in the cartilaginous fish, we've got our sharks and our rays, which we are going to spend the most time on, but there is another group of cartilaginous fish, the chimeras, which is also the name of a mythical creature. These are deep sea cartilaginous fish that are really, really neat, okay? So people ask me all the time, aren't sharks and rays the only cartilaginous fish? No, they're not. They are Elasmobranchs. So underneath cartilaginous fish, the class Chondrichthyes, we have a subclass, okay? And the skates and the rays and the sawfish and the sharks are all Elasmobranchs, okay? Subclass Elasmobranchii. Okay, so they could be shaped like your typical shark, okay, where these guys have these really big pectoral fins, okay, that they use like an airplane wing to give them lift, okay. These guys have gill openings, okay, rather than one gill opening. These guys have gill slits right here. And then to me, one of the neatest things about sharks is their big caudal fin right here, okay? So you can see their tail fin, the top lobe is much bigger than the bottom lobe. It's called a heterocecal tail, okay? A bony fish, like a bass or something, I could not think of a bony fish just now, even though there's thousands, a tuna, whatever, their tail is the same size, okay? On both sides, both lobes, okay? Anyone know the most famous of these sharks as far as their tail goes that has the most, how am I trying to say this, that has the biggest change in their tail? The thresher shark. And I want to stop my share for a second. Hi everyone, because I want to show you a video, okay? So Mr. Brad is actually on the call and he's moderating, answering your questions, and he actually saw a thresher shark in the wild. So I want to show you his video, and I want you guys to look at the tail, okay? Also look at the eye, okay? That's going to give you an idea of where these animals live, okay? Usually the bigger the eyes, they're in that sort of midnight or twilight zone, okay? So they're not all the way in the deep sea like the anglerfish. The bigger the eyes, the better, okay? So these guys are deep, but not the deepest, okay? So let me show you guys. It's a quick video. Look at that. Wow. Amazing. So they use that tail for all sorts of things, for swimming, for balance, to help when they are hunting. It's a pretty incredible adaptation of these animals. And of course, in the Elasmobranchs are also your skates and rays. These are basically like flattened out sharks, okay? So their body shape is called dorso-ventrally flattened. Say that 3 times fast. I can't do it. So you can see that means their top and their bottom are squished together. They're flat. A flounder would also be considered that shape, okay? So where's your sharks or that fusiform torpedo shape? These guys are your dorso-ventrally flattened shape, okay? They're flat sharks, basically. So one of the things that makes an elasmobranch is the skin, okay? So this is a up close picture of the dermal-denticles, okay? These are special scales. The type of scale is called a placoid scale, and a placoid basically means teeth-like. So this is magnified by 1,000 or so, okay? And all sharks have different dermal-denticles, skin, teeth, okay? They're all pointed the same direction to help them glide through the water. Think about your cat or your dog. When you pet them head to toe, okay, or head to tail, all the fur lays flat. It's all pointing in the same way. But if you go tail to head, then it changes and it kind of feels rough. It's because they're all laying the same direction. And the same thing with these dermal-denticles. So if you guys look, this is a piece of shark skin. It's almost like leather that's covered in sandpaper, okay? Really, really thick, okay? Because when they mate, they may bite onto each other. Their prey may bite onto each other. So they have to have this really thick skin. Back in the day, people used to use it as sandpaper. If you feel it, you feel this way, it's really, really smooth. You go this way, it's really, really rough, okay? Very similar to sandpaper. Luckily, they don't use the skin for sandpaper anymore, but yeah, that very, very thick. Okay. So that's one thing makes an elasmobranch, those dermal-denticles. Another one, which is my favorite thing about an elasmobranch, are the teeth, okay? So you guys may remember this word when we talked about alligators. We also used it when we talked about manatees. Does anybody remember what the word polyphyodont means? I will give you a virtual high five if you remember polyphyodont, okay? And for sharks, I'll give you a hint. It has something to do with all these rows. Yeah, good job, guys. It means many teeth. Basically, they have a never-ending supply of teeth, okay? And I feel like sharks are the most famous polyphyodont, okay? Because how many of you guys have found a shark's tooth on the beach or in the water? Most of us, right? It's not that there's a bunch of sharks dying out there, which, I mean, there are, unfortunately, but they're also losing those teeth a lot, okay? So that shark could still be out there living and swimming around, okay? Now, depending on how old it is and where it's been living is gonna depend on the color, okay? So if you find one that's really, really dark or black, it's probably really old, it's probably fossilized, it's probably been underground for a while. So you can see some of the different types of teeth, okay? So I have some to show you guys. So I just love this fact about sharks because, again, a lot of people think that sharks are just mindless eating machines, right? And they're just going after whatever they can find. That is not the case, all right? They have specific diets and specific needs, and their teeth are really good giveaways of that, okay? So depending on what they eat could depend on what their teeth looks like. So if you look at this, so if you think about us, when you go to eat a bowl of ice cream, what do you use to eat it? A knife? No, right? You'd look silly, right? It would be hard. A spoon. You have a nice piece of steak or tofu, you got to use a knife and a fork, okay? A salad, have you ever tried to eat a salad with a spoon? It's impossible. You got to use a fork, okay? So, sharks are the same way, all right? Depending on what they eat is how their mouth has adapted. So check this guy out. This is the jaw from a lemon shark, okay? Now, if you guys were here, I'd let you feel that and you would see that they're pointy teeth and they're very, very smooth, okay? That's because these guys are using their teeth like forks to grab small, slippery prey, like maybe small fish, maybe a little octopus or something like that. So the lemon shark has these built-in forks. Now, when he loses one, another one pops into place like a conveyor belt. Really neat. Now, if you look at something like this guy, this is from the fastest of all the sharks. This is the mako shark. Check out those gnarly teeth, you guys. So the mako, again, they're swimming fast and they're hunting fast, right? So they're going after fast fish, maybe bigger fish. And when that fish goes in the mouth, if they turn around to try to escape, they've got all of those shark's teeth pointing right back at them and they're going nowhere, okay? So check out this guy. Whoa. This is from any guesses before I give it away? This is a sawfish, which is an amazing animal. They are a critically endangered species of, or Elasmobranch. So they're technically a ray, but they are an Elasmobranch, so they share all these same characteristics. They use their saw to basically grab prey. So their mouth is here, and as they're swimming through, they're pushing their head back and forth. Maybe a fish gets stuck here. Maybe they're stirring up some fish. So really utilizing these like tools. Last one I want to show you. Check out this guy. Who's this from? The most famous of all the extinct sharks, right? This is the megalodon, okay? And this isn't even as big as they got, okay? But it's the basic same shape as a great white shark, okay? So a great white shark's about this big. So you can tell a lot from the tooth, okay? They say for every 1 inch of the tooth is about a 10-foot worth of shark, okay? So you can use your imagination with this one, okay? And then the great white is actually serrated around the edges, okay? So it's almost like they have a fork on the bottom and they have knives on the top. So they grab their prey with their bottom and they move the top jaw back and forth. I almost forgot my favorite jaw to show you. Look at this guy. All right, check out these teeth. It's hard for me to see what I'm showing you. Any guesses what shark this is from? These guys have special little lobes on the tops of their teeth that allow their teeth to almost act like a can opener. Oh, good job, Roger. Tiger, very good. The tiger shark. So their teeth almost act like a can opener. And when they bite into their favorite prey, which is a sea turtle, sorry for the sea turtles, but it's all natural. They bite and they're actually able to twist and open that shell up almost like a can opener, which is wild. Now, tiger sharks have been known to eat a bunch of random stuff. So they're probably the least specialized of our sharks, but they're amazing. Circle of life, you got it. Okay. So another thing, guys, that makes our Elasmobranchs so perfectly adapted to living in the sea, and something that's a little bit different from our bony fish, is their unique buoyancy control. Now, buoyancy, if you guys remember, we've done a couple things for buoyancy in these classes. That's basically your ability to float, okay? Most animals in the ocean want what's called neutral buoyancy, right? Because if they're floating or they're sinking, they're having a hard time moving around. They can't really, there's for fish or sharks, you want to be kind of in the middle of the water column. So these guys don't have what's called a swim bladder, which is what most bony fish have, that they can blow up and down almost like a balloon. These guys have a really weird organ that's about 25% of their body. This is Dr. Carl Lohr back in the 70s. Any guesses what organ this is? Pop quiz. Something that helps to give the shark its unique buoyancy, making it not sink. It is filled with a substance called squalene that makes it very, very oily. And I'll give you another hint. It also helps with detoxification and helps with their immune system. Sharks help us keep diseased fish out of the food supply because they have such a strong immune system. They can eat these fish and not be affected. It's the liver. You got it, the liver. So guys, a shark's liver is really, really oily. And if you guys have ever done a density experiment with oil and water, it's pretty simple, okay? The oil is less dense, okay, than the water. So the oily liver is also filled with water. So anytime the shark is moving around, that liver is keeping it buoyant and keeping it upright because the oil is always going to stay at the top, okay? So you guys can kind of play around with that. And then their special pectoral fins also help with that as well, give them that lift. Good job, guys. The weird liver of the shark. They also, that helps them to have that strong immune system. So boys and girls, these are some of our cow nose rays that live in the touch tank at Mote Aquarium. So hopefully you guys will get to come back very soon and touch these guys. That might not be for later, so fingers crossed that everything goes back to normal soon. But when you do come back and are able to touch them, what I want you to do is feel their slime. So they have that special slime layer that helps support that immune system in addition to those oily livers, okay? So that slime almost acts like an antibiotic. So if you guys have ever had a cut and had to put Neosporin on it or that antibiotic ointment, it's almost like these stingrays are covered in that, okay? Scientists have found that they have, that they very rarely get infected if they get cuts or anything, and they contribute that to that slime. Now these guys also have a special organ called the epigonal gland, and that's what Dr. Lohr believes is helping to contribute their low rates of cancer. Okay, so there's still lots of research to be done, but pretty incredible what we may be able to learn from these Elasmobranchs and their ability to heal. All right, last thing I want to share with you guys about the sharks are their highly adapted sensory systems, okay? Their senses. That's what we use to survive, right? Our senses, okay? If we start to smell something burning, okay, we're going to go the other way. If you go into a room and you smell popcorn, okay, or you hear it popping, you might head towards it. If you hear a scary monster or something, you're not going to go in that direction. So using our senses to both find food, to find shelter, to survive, to avoid danger, okay? Sharks have to do the same. Guys, how many senses do sharks have? Do they have the same senses as us? Do they have different senses? What do you guys think? They have one extra sense than us. You guys got it. They have everything we have and electroreception. Okay, so this is one of the big things that makes an elasmobranch an elasmobranch is this electroreception. So I'm going to play this quick PBS video for you guys that kind of goes over this special sixth sense that our sharks have.
We live in a world full of electric fields. Animals, plants, even the earth itself creates them, but only a handful of creatures can actually sense them. Sharks, also rays and skates, a whole group, animals called Elasmobranchs, can actually detect electricity. Maybe it's like feeling the presence of someone hiding in a dark room. A different way of experiencing their world, an extra sense that we don't have. And for sharks and rays, an extra edge for finding their prey. The discovery of this exceptional sense dates back 300 years, long before the discovery of electricity, to a man named Stefano Lorenzini. Lorenzini was a doctor with a passion for anatomy who one day found himself dissecting a ray, which is where he noticed the strangest thing: tiny pores that dotted the ray's skin. He drew a picture. It shows how each pore led to a tube full of goo, and each tube ended in a little pouch. Those little round pouches reminded him of ancient Roman flasks called ampullae, so that's what he called them. But when it came to the function of those ampullae, Lorenzini was stumped. 3 centuries later, we're still figuring out exactly how electroreception works. And a big part of that is studying what makes these electric fields in the first place. Every time this fish opens its mouth to breathe, it exposes its mucous membranes to the salty water, creating a tiny voltage that disappears every time the mouth closes. At Florida Atlantic University, scientists are actually able to measure this phenomenon. That repeating on-off pattern is an electric frequency carried easily through salt water. 2 hertz, 2 breaths a second. Stingrays like these can tune into that same frequency, like a radio channel. Take a close look at a stingray and you can see those pores. They lead to long canals that cluster together. When an electric charge enters a pore, it travels through the highly conductive gel in the canal to the ampulla, where special cells detect the current and send a message along nerves to the brain. That's how stingrays can spot prey hidden beneath them, even though their eyes are on top of their heads. But the ampullae aren't just for hunting. Pores on the ray's back also let it know if someone's trying to sneak up on it from behind. Here, the researchers placed diodes on the floor of a tank, replicating the same electric frequency as a breathing fish. They flip the current from circle to circle, and the ray strikes the active target. Maybe by studying how this sense works, we can learn better ways to coexist with these ancient creatures. Find new ways to keep them out of our nets and away from our surfers. Of course, none of this really explains what it's like to feel electricity. Is it as simple as flipping a switch on and off, or as varied and subtle as smell or taste? A whole spectrum of experiences hidden from the rest of us.
So cool. So hard to explain what a sense must be like that we don't have, right? So they can pick up on that electrical vibration. So basically this video is telling us that everything is putting out a little bit of an electrical vibration through movement in the water. But another thing, guys, is our hearts, okay? So fish heartbeats, if they are diseased or dying, their heartbeat changes, okay? And the sharks can actually pick up on that. They can pick up on that in more ways than the electroreception too. Okay, they can see, so they definitely have really good vision. Now, the one thing I want to point out about their vision is they have this third eyelid, okay? They have the nictitating membrane. Let's all say it together, nictitating membrane. You guys can sing it if you want, okay? So that nictitating membrane protects their eyes. Now, their eyes, this is a blue shark, their eyes are on both sides of their head. That gives them a 360-degree view. So they can almost see all the way around them. Pretty incredible vision. Now their hearing and touch is also really highly developed, okay? And their hearing and touch kind of work together, okay? They can hear directionally, okay? So they're really good at picking up the direction of sound, okay? And the hearing and touch, it's also kind of related to the electroreception. It's all kind of connected. So guys, if there's any sort of vibration in the water, that the electroreceptors don't pick up on, this lateral line can actually pick up on it. And then it actually sends a signal through their ears to their brain. So it's all kind of connected, which is wild to think about, okay? We'll talk about that in a second. So this lateral line is sensing change in pressure around them. Now, our scientists at Mote have found that these guys can sense a storm coming. So if a hurricane or something is about to hit, they can actually sense it. Kind of like if any of your parents have bad knees or anything, or if you guys have ever had knee surgery and like a storm's coming and your knee kind of starts to hurt, it's because you're sensing that change in pressure. And that's what these guys can do as well. So they can hear in certain directions, they can sense the change in pressure, okay? Now, another thing with touch is these guys will use it to basically explore. Think about us. Now, if you guys gathered 10 random objects, like I told you to on the lesson plan, go ahead and get those out and put them in front of you. No worries if you didn't. But basically what I want you to do is explore your different senses in trying to figure out what those items are, okay? So one thing that a shark will have to do if it's murky water and it comes across something, say the lateral line's not picking it up, maybe the electroreception's not picking it up, they'll actually bump it with their snout, okay? Usually as soon as they bump it, they figure out what it is and they turn and leave, okay? This is what we call a shark encounter. Unfortunately, a lot of people, if that happens to them, they will call it an attack, but it's not. It's just an encounter and it's just them kind of figuring out, well, what's going on. You guys can do the same thing, okay? If you have a bunch of random stuff in front of you, go ahead and kind of mix them up. Close your eyes and touch the different objects, okay? Can you tell them apart just by touching them, okay? If you are touching them but you still don't know, can you pick it up and listen to it, okay? So use different senses to try to figure out what you have in front of you, which is kind of fun. Now their smell and their taste is also connected. That's what I started to talk about on the last one. Just like us, think about guys, when you are sick, have you ever tried to eat something and you can't really taste it, right? So let's try that now, okay? If you got permission from your parents to get, I had you get a tiny pinch of salt and a tiny pinch of sugar, or a tiny piece of apple and a tiny piece of pear, okay? First thing I want you to do is look at the two and figure out if you can see the difference, okay? What sense are you gonna have to use to figure it out? So let me stop for a second. So I have my salt and my sugar, okay? They literally look identical. The only way I can tell them apart is by tasting them. So, good thing I like salt and sugar. I'm gonna go with the right one. I'm gonna say the right one is salt. Yes, I was right. That was purely a guess. So you guys can do that, explore that. Then, try to taste while holding your nose, okay? Again, our taste and our smell work together, okay? So if you have that piece of apple and you have that piece of pear, okay, close your nose or hold your nose and take a bite of them. You can't really tell the difference. It's really wild. So practice that, okay? Taste different things with both your nose plugged and your nose not plugged and see if you can tell the difference, okay? So just exploring our senses. So I'm just going to go through these really fast, guys. So these guys also have really specialized reproductive strategies, which makes sharks so vulnerable, okay? So it takes them a long time to have offspring, okay? Which is different than bony fish. Now the boys have these long claspers, and there's a couple different ways they can reproduce. They can have eggs, okay? Like a horn shark, or like a skate. Okay, Oviparity. Okay, they could be oviparous. They could have what's called placental I can never say it. You guys know I'm terrible at pronouncing words. Viviparity, okay? This is live birth, okay? So these guys are more similar to the way a mammal gives birth, okay? So like the great hammerhead, the bonnethead sharks, they lay live birth. And then the last one is called Aplacental Viviparity, okay? These are basically the eggs hatch inside the mom's body. But what's really wild is they do something called interuterine cannibalism, which means the brothers and sisters, survival of the fittest, okay? The strongest sibling in the mom's belly eats the other babies. Man, that is sibling rivalry right there. So go ahead, if you have brothers and sisters, thank them for not consuming you while in your mom's belly, okay? Because that's what these guys do. White sharks, sand tiger sharks. So that is survival of the fittest right there. So because of all these things, these sharks are vital to our ecosystem, okay? They are important. They reproduce slowly. They are vulnerable. Here's just a couple more reasons why they're so important. They keep the balance of the ecosystem. They're apex predators, okay? Lower trophic levels would overpopulate. They prevent the spread of diseases by eating those fish, okay? All those biomedical applications we talked about, wound healing, low rates of cancer. Important for fisheries to keep that balance, right? So we have plenty of fish. Tourism, people coming to see these guys, which all drives our economy, especially here in Florida, okay? And of course, they're just awesome. They are just amazing, really, really cool animals that kind of have a bad rap. They face a lot of threats, ladies and gentlemen, okay? So illegal fishing practices, whereas people taking them when they're not supposed to, pulling them out on the boat to take pictures of them can actually stress them out, like a hammerhead or a shark that's protected. Pulling them onto the boat, most scientists have found that that can actually harm them, okay? Things like climate change and change in the environment is causing their prey to go to different areas, okay? And they're having a hard time finding it. They're getting caught in fishing nets, okay? So we've learned in the past that bycatch is a non-targeted species. So if they're after salmon or whatever and they accidentally catch a shark, that's bycatch, okay? So these are unsustainable fishing practices. And then of course, we all know how dangerous any sort of marine debris, plastic, fishing line left in the ocean can be on all of our animals, not just sharks, okay? There are a couple things that we can do. Okay. Oh, another illegal fishing practice. This is shark fin soup. I'm sure you guys have heard of shark fin soup, right? So sharks need their fins. We don't need them, right? Couple of easy things you guys can do to help our sharks, okay? They need us. They have a lot of people out there against them, okay? So this last one is the most important. You guys are learning now how to take care of the ocean. You are my moat warriors. You're my shark warriors. You're going to save the world and save the planet. Pat yourself on the back. Tell a friend how cool they are. Tell them those shark safety tips, okay? That usually helps people feel a little bit better. Take better care of your environment, okay? These are all things that can help. Now, supporting sustainable seafood, we've talked about that in the past. You can download the Seafood Watch app. We want to make sure there's plenty of food left in there for everybody, right? If you end up catching a shark, okay, rather than pulling it on the boat to take a picture, go ahead and try to get the hook out or simply clip the line. We don't want a lot of fishing line and hooks in our oceans, right? But if you can't safely get it out, that's almost better than bringing the shark up on the boat, okay? So do your research on that. Visit mote.org/research, and that'll tell you a lot more about things we've learned about sharks. And then the last one I want to tell you about is not purchasing these jaws or preserved specimens. If you go to a tourist shop or somewhere that sells a bunch of stuff, ask them where their shark jaws came from before you buy it, because you don't ever want to buy something that has been killed simply so you can have a decoration. Not what a moat warrior does, not what an ocean conservationist does. So, you know, you may have to have your parents ask where it actually comes from. And if they don't know, it's probably best that you just don't even buy it, okay? So any preserved specimens, sometimes they'll sell baby ones in jars. Now, sharks' teeth are a different story because we know, being polyphyodonts, they lose those teeth, okay? So if you find shark's teeth, by all means, collect them and show us your collection, because that would be really fun. Well, ladies and gentlemen, I can't believe it. It's right at 2 o'clock. It was exactly an hour. I just want to thank you guys so much for your support in this program, At Home with Mote. It's been a blast. I want you guys to go out there, save the world. Fingers crossed that we can be together in person in the fall. But the virtual fun is not over. So if you did not get a chance to write down the info for our awesome summer, please do that. Now, guys, space is really limited, okay? June 8th is the first camp, and yours truly is going to be one of the counselors for the first camp. I'm aquarium biologist in training. It's going to be so much fun, okay? So everybody, make sure you get a spot as soon as this class is over. Go to mote.org/educationonline and register for some really fun virtual programs. Let us know what you think. If you end up making some smell canisters and smell it, let us know. Take a picture, post them at Home with Mote. Tell us how if you've enjoyed these classes. And yeah, I hope you guys have a beautiful day. Thank you again. Coming to you from Mote. I hope I see you all soon. Go out there, save the world, save the planet, and we'll see you next time. We'll see you for an awesome summer. Bye, guys.